Okay guys, so this video is going to be about combinations versus permutations. I'll also show you how to do combination problems. Okay, let's get started on what is a combination. A combination, the order of selection does not matter. So which means that if you have, let's give an example of let's do like a movie. Let's say on Saturday you want to watch movie A, and then you want to watch movie B, okay? And then does not matter, meaning that if you want to watch movie A and you want to watch movie B next, that's represented. So represented in if you want to watch movie B first and then movie A next. So these are represented, which means that combinations is going to have fewer, usually have fewer fewer numbers, all right? Whereas in permutation, let's say there's runners, okay? There's runner Bob and runner J, right? So runner J, for this case, the order of selection does matter, because if you're running a race, right, they're like who finishes first. So this case, the selection of either Bob finishes first or J finishes first matters. So that this is what does it mean by order does not matter, order does matter. So I'll give you some more examples if you don't get this, but let's go on. So there's two of them, they don't have duplicates, but for combination, they usually perform equal jobs. The objects in the story or in the word problem perform equal jobs. And in permutation, it's not equal jobs. And usually in combinations, it talks about groups, so of grouping something together, whereas in permutation, it's usually about ranging something together. All right? Let's give some examples to know what is a permutation and what is a permutation problem. All right, so this one, the math club needs 5 members committee to determine which competitions to attend next year. How many different possible committees can be chosen? The key word here is committees. Committees is like a group, right? So which fits under the definition of combination because it talks about groups. So we know that we use combination to solve this problem. How about this one? Rather than having sampler bags with 3 different cookies, the bakery now wants to make sampler bags with 4 different types of cookies. Now, how many sampler bags are possible? Now, sampler bags are a group, right? So, which means that we have to use combination. So, easy enough to figure out groups. Now, let's do a harder one. Well, let's do permutation example first. Next. Let's see. Let's do this one. 8 runners are racing in a 200-meter dash. In how many different sequences can runners finish the race? So we know that each of the runners run at a different pace. So that means that they perform a different task or job. So not equal job, meaning permutation to solve this problem. Or right here, we have puzzles in this case. Now each individual puzzle is like this unique. So that's why we have this one is it does different jobs, and different jobs means it's a permutation to solve this problem. Now we have to identify what is combination and permutation. Let's talk about the combination formula. This is going to be the permutation or combination formula. So n factorial over n minus k parentheses factorial times k factorial. Whereas n, you know, that is the total number of items, and k is what you select, right? what you select. Okay, let's do an example of a combination. Okay, so which one is a good one? This one. We read this one before. It's the math club one. Needs 5 members committee to determine which competitions to attend next year. How many different possible committees can be chosen? Now, they don't tell you how much total members are there, but there's 40 members. Okay, there's 40 members. They need 5-member committee. Okay, so they are talking about groups, right? So let's do our combination formula. Okay, so n equals 40 members. All right, where k is we want 5-member committees, so we want 5. So let's plug in the formula. We got 40 permutation, 40 minus 5 permutation times 5 permutation. So if we simplify, it's 5 permutation, right? And that's gonna be our answer. You guys know how to put in the calculator already. Oops. So like that, right? You plug in the formula and it's right because I checked the answer right here. So yeah, so this is how you do it for this question. Next problem. I'm going a little fast here because you guys should like understand it more now. So going a little fast. Okay, let's do this one. 4 copies of science textbook and 5 copies of social science textbook or social studies textbook on a bookshelf. How many possible arrangements of textbook are there? Okay, now this one is definitely combination. How you know? Because the 4 copies of science textbook are like the same. Like they're like the same science textbook and 4 or 5 social studies textbook, and they're like exact copies of each other. So they perform the same jobs, right? So this is why it's a combination. So let's solve it now. So let's solve it. So we know that there is a 4 copies of science and 5 social studies. So that means total 9, right? But then we have to arrange it in a way that they have arrangements. So how do we figure this out? Let's see. Okay, so the 4 science books could be placed in any of the 9 spots on the bookshelf, and then the social science book would be placed on the leftover spots. Okay, so it looks like so basically what it is explaining is that the science textbook can be matched with the social science textbook, right? And they will repeat it for like 2, 4, 6, 8. So there'll be like 4 times, repeat 4 times, like 4 matches, right? And then there's one lonely one who's gonna just put on a leftover spot. Okay, so if we pair them out or pair them up, then we have we can pair them up 4 times. Okay, so which means that we can do 4 right here because we're selecting 4 times, right? 4 times to pair them up to each other. So yeah, and then you plug in the formula now. We get 9 factorial times, so remember the formula, it is going to be n minus k, right? So n minus k factorial times 4 factorial, right? Yeah. All right. So now we double check. I haven't done this problem, so let's double check the answer. Oh, oopsies. Over 5 5 1 times 4 factorial -5 1. Okay, ready? Oh wait, it's wrong. Okay, this is why you need to put parentheses, because it's easy to get it wrong. Okay, let me delete this one. And then you put in the parentheses right here. And bam. See, 126. Make sure to put parentheses on the bottom, or else it will end like that, which we don't want that. We want this. So yeah, equals 126, and that is your answer. All right, so this one is a little bit weird. You have to think about it, but you generally want them to be paired up to each other, but you can do that 4 times. So you would do k equals 4 because we're putting in groups of 4. Okay, groups of 4 in this case. Oh yeah, and also it's a good way to think about it as groups. Okay, k as groups. I think that's a better way of thinking about it. If you see, you can see that 4-time group, right? And then remember, the last problem is like 5 committees, so 5 groups. So k equals 5 on the previous one. So yeah.